my name is Einat. I'm from Tel Aviv. I'm the co-founder of Reverse and part of the team that develops LakeFS. My talk is going to be about data versioning. We're going to review data versioning tools and cluster them according to use cases. It's going to be fun.
Hello, everyone. We're going to spend this session talking about data versioning. Or actually, does it mean what you think it means? Because apparently it means a lot of things. Just a little bit about me before we continue with the subject. So I come from a technical background. I'm currently the co-founder of CEO of Reverse, the company behind an open source project called LakeFS that I will mention later in the presentation. Previously, I led R&D organizations with Israeli startup companies. Most recently, I was the CTO of SimilarWeb, a very large data company. And I have a PhD in mathematics from Tel Aviv University. When I still worked with my hands, I was an algorithms developer, or what is now referred to as a data scientist. So let's just jump into data versioning. We'll talk about how this thing came about and where we see it. And then we will just cluster the tools that provide data versioning to 4 different groups. And once we've done that and we're clear about the classification, you'll be able to ask some questions about the content of the presentation. Where do we see data versioning? So the answer would probably be everywhere. So all the tools that you see their logos here provide some sort of data versioning, or Git for data, or any other form of manage your data, the way you manage your code, or any other form of expressing the need to get some versioning within the data. But when you dive into all those tools, which is something that we did when we first thought about LakeFS, we realized they were doing things that were completely different in nature, and they were also providing solutions from completely different use cases, which is where we thought it would be a good idea to try and cluster them and understand what problems they solve and why. So I'm not sure if you're familiar with clustering. I did my PhD on weighted clustering, so kind of my favorite subject. So the thing is, you're trying to separate things that have stuff in common, but you want to separate them in a really good way. So you need your clusters to be as far as possible from one another and also very dense within themselves. Let's see if I succeeded in doing that. There were quite a few ways we could have classified the data or the tools, but at the end we thought use cases is probably the way that separates the tools from one another in the best form. So what are the use cases and what are the classifications? So the first classification, actually the first cluster, actually the first and the second cluster come from the world of ML management. So ML pipeline management would be the process in which you start with a training set and a model and the hyperparameters of the model, throughout maybe increasing your learning set by further tagging data, throughout adjusting the parameters, and all the way to bringing it into production. So this is a very wide area that includes very many tools. Some of those tools also provide data versioning as part of allowing you to manage your entire ML process. So clearly this is a very partial list. So was the first list I've seen. We're only looking at examples, but the tools that you see here provide some level of versioning to the data that is being used within the models. And it is doing that in order to allow you to properly manage the data throughout the ML process. Basically, it means that it combines the code, the data that is required to train a model, the configuration of the model, and version all of them to a version of the model. So all 4 are a repository that is versioned, so you can easily go back and in time to a certain point in your development of the model and have a coherent set of code and data that were used to create the model that you're looking at. This specific screenshot is taken from the documentation of DVC, data version control, which is one of the tools that provides data versioning for ML experiments. Okay, so why would you be looking in this group? So you're a data scientist, you're obviously running ML pipelines, and you need somehow to scale your work, and you need additional management tools, and you feel that data versioning is part of what you need. You need a time travel within your models. Do note that if you are using one of the tools within this group, it would not only version the data for you, it provides you, for better and worse, a complete work environment for managing your ML processes. So a lot of your good work is going to change together with getting the data versioning that you were looking for. So this is the first group. The second group is very adjacent to it. It was difficult to separate them. And is also a rather big cluster in the sense that the elements within it are a bit different from one another. But what is in common for all of them is collaboration. So those are tools that allow you to collaborate. Here are the examples. So we can see here tools that manage versioning of data that is a universal data set that is provided to researchers all around the world, such as Data World or Kaggle. In some cases, some of the members of this group also manage ML models together with data. If we want to really look at the spectrum that we cover here, so collaborating over data, if I start from the left-hand side, would start with Dolt Hub, which is actually a technology. They do not hold any data by themselves. They are encouraging you to hold your own data within the Dolt Hub, which is their managed service. And this database that they provide actually provides Git-like capabilities, and within that, of course, very strong capabilities of version control. So this is one end of this spectrum where you collaborate over a data using a technology. In the middle, we have the Kaggles of the world, and again, there are quite a few of those, that provide universal data and sometimes model repository that is versioned over time. Again, you can time travel between different versions of a model to a problem, together with all the data sets relevant to creating that model. And this is a service, so this is something that is shared and collaborated between many organizations. And then at the end of that, you have the DUGS Hub, which is actually based on DVC for data versioning, but allows also collaboration over models and takes it to an even higher degree of collaboration in the sense that it's the GitHub for data science. So you can have a pull request for a model, and you can actually manage in collaboration the entire logic of an ML process or an ML model between companies even. So this is their vision. This is all one group because all the data versioning offered within those groups is meant to allow collaboration, still mostly around ML models and other algorithmic work. So if you'll be looking into this group, you are probably wanting to collaborate over your research work, right? So you are a data scientist or someone else providing services to data scientists, and collaboration is something that is required and you don't have. And together with that, part of the collaboration would be versioning of the data and Git-like operations over the aspects that are managed by those tools. And it also provides, as a side benefit, a single access to all the data that is being mirrored through those systems. Those systems don't necessarily manage the data like the DOLT hubs of the world, but rather provide an interface to your existing data sources, such as object stores and databases. But still, the access is done through those tools to allow smoother collaboration. Okay, so now we are going to do a quantum leap and leave the world of MLOps. So data scientists aside, we have trouble collaborating and managing data and versioning of data, even if we simply need an ETL or just a join of a few data sets that are being updated frequently. And usually when we manage this data, we manage it in an immutable world because we are using object storages. So we have moved from the world of ML ops to the world of data ops and the world of object storages, such as S3, Google Cloud Storage, Azure Blob, or if you are using it on-prem, MinIO, Pure, the list is very long. But those are the state-of-the-art data lakes nowadays because they allow high throughput and very cost-effective. The thing with them is that they are immutable. And with data, especially BI data, we need some mutability. So let's dig into that. The tools that would provide us over an object storage mutability are data formats. Those are not tools, those are data formats, Hoodie, Iceberg, and Delta Lake, and Apache ORC. And all those formats provide some sort of data versioning throughout the metadata that they manage. So again, to frame the world, you manage your data over an object storage. You want to be able to have mutability, which is to respond to changing data in a world where once an object is written to an object storage, it cannot be changed. So we are trying to create mutability in a world of immutable rules. And this is exactly what those four formats do. How do they do that? I took one example here, but all of them work in the same way, more or less, at least logically. They're very, very different with the advantages and disadvantages if you really dig in. But in high level, they'll all do the same thing. So you save one version of the data, and then arrives a backfill, additional data, a request to delete data. So all those changes are saved in the next file, together with metadata that describes the connection between the two files, that what had changed. So over time, what you have is very many files describing the evolution of the data and very many metadata files that allows you, when you query the data, to get the latest view of the data by actually merging the files into one coherent view of the data. So this is the logic by which those tools work, or formats, work. And this turns the immutable picture of an object storage to a mutable data set. So this is all great. How is that related to data versioning? So it's actually a byproduct. In order to make sure you have concurrency and that you can read and provide performance, you save those deltas of data, and hence you can decide to go back and read the status of the data the way it was a few days ago. Again, you would just be taking the end point of your read from the time you're interested in, and then look at the files from there back in history, merge them, and get the picture the way it was in that point of time. It just works that way and allows you, over this one single axis, on the one single table that you are managing, to move in time back and forth. Those time travels are usually short time travels because the performance in read is influenced by the amount of history that you have decided to save unvacuumed. It means that you haven't yet joined it to one representing file and moved forward. So there are some configuration games there that are history versus performance considerations to be taken. And hence, as a rule, the time travel is short-lived, but it exists and it's extremely useful. So this is where we actually get mutability. And also time travel as a very nice sidekick. So who would be using this? So clearly companies who have their data lake over an object storage, and they have structured BI data that changes over time. So they live in an immutable world and need immutability. And in that case, any of those formats would do an excellent work. As a byproduct, it would also provide ACID guarantees. We will not dig into that so that we can go over the entire presentation on time. And it allows also short time travel. So the time travel is actually the versioning of the data. If you can time travel back and forth on the same table, then you are you have traveled through time, but also it means that the versions of the data are still there. So this is becoming Iceberg, Delta Lake, and Hoodie are becoming more and more popular within companies that are managing their BI data in an object storage and not in a database. Okay, now the last use case is, oh, I see I have a lot of time. I was running through it because I was afraid I won't have time. Okay, so let's slow down a little and dig into this one, my favorite. So what about data lake manageability? Here we are still in the world where we are managing our data in an immutable object storage. And we may also be using one of the formats that I have mentioned earlier to make sure that our data is mutable in the cases we need it to be mutable. But this doesn't solve our manageability problem. And what do I mean by manageability problem? So, not surprising, the tool that we have in this group is LakeFS. It's the only tool we know so far to be doing this in a format agnostic way. So it is suitable for any format you would be using, including, as I said, Delta Lake or Hoodie or Iceberg. And what is it going to do for you? So it is going actually to allow you a layer of manageability over the object storage. So I'm not sure how familiar you are with working over an object storage, but if you did, you have deleted data that you did not want to delete at least once in your life. It's a rule, it happens to everyone. And the reason is this is the guarantees that an object storage provides. If you accidentally save to the same place with the same name, you'll run over the data that was there, you get no warning, the data is gone. Of course, there are recovery capabilities of a storage, but those take a long time. So once we understand the disadvantages of object storages, we want to try and create a more resilient environment when we're using them. Now, not to sound as if I'm objecting to object storages, actually, I'm a big fan. This is an extremely cost-effective, high-throughput way of creating a data lake and managing your data. So it just requires some additional capabilities over it that allows us to work in a resilient way. And what would we be wanting to do? We would want to create, for example, a development environment for data. How would we be doing that? With LakeFS, which is a kind of a Git interface over your object storage. So think Git for a moment. I'm sure you're managing code with Git. So if you want to experiment, you can now open a branch of your data lake. This is not a copy operation. No data is being copied. When you create a branch, you only play with metadata. like in Git. And now you can experiment on that branch. You can rewrite things, you can delete half of the data lake, you can run experiments, ML experiments, for example. And when you do that, only your branch is being influenced. And of course, since this is Git, in a Git logic, you can go back and forth in time on your branch. So if you made a mistake in your experiment, you can revert to a point in time within your branch. While you are doing all those games and you are playing in isolation, the actual data lake, the master of your data lake, is not touched. No one sees anything that you do. You work in complete isolation. And then you can have reproducibility. As I said, you can go back just to the last commit or to the commit before or to any place within the history of your branch that you have tagged. And you can run several experiments or several data pipelines in parallel on different branches, and then compare the results very easily through the UI or the CLI of LakeFS. So this is one capability. Today, over an object storage, it's difficult to create a development environment. And it takes a lot of work and a lot of DevOps work, and organizations who have started working with data 6 or 8 or 12 years ago have probably done some of that engineering themselves to allow themselves working with data. And they have created several different solutions to allow themselves development environments, depending on the problem. And here, LakeFS allows one very simple interface in a language that is known to everyone because it's Git-like, that allows you to work in isolation on your experiments. And only when you're done, decide whether to merge something to master or to just discard the branches of the experiment and go on with your life. By the way, experiments are not only ML experiments, in case this is the association that you have. Even if you need to just upgrade your Spark version, for example, or your Presto version, or you want to compare whether you should do some operation on your data using Spark or using Presto, which one would be better? All those things could be done easily as experiments over LakeFS with different branches of data. This is why this tool is much wider. It is not only meant for machine learning engineers, although they are, of course, capable of using it. It's wider in that sense, but it's also very general. It only deals with Git-like operations over your data, so it only deals with data versioning. Let's give 2 additional examples, and then I'll go back to this point. So continuous data integration. This is the case where you constantly have new data sets that are coming in to the organization or to your application from many parts of the organization. And you need to make sure that those new data sets adhere to good practices that your organization has. If it's PII, if it's the format, if it's the schema, anything else that comes to mind that you need to validate before you allow this data set to set foot in your data lake. How do you do that? So if you have a branch of the data that is an ingestion branch, you can ingest the data into that branch. While you do that, the master of the data, which is where everyone works, cannot see this new data and can't access it. Now you can run testing on this new data that arrives to the organization. So this is a way of actually automating the process of getting new data sets into production. And the third really needed capability that we're missing over object storages is the ability to continuously deploy data. So think about a use case where you haven't changed the code of your, again, ETLs, algorithms, everything that you're running over the lake. So no code changes. You haven't changed the version of anything. Everything is stable in your environment. Still, we are constantly ingesting new data from the existing data sets, right? So yesterday we had yesterday's data. Today we have today's data. If you're working in higher frequency environments, it could be the data of the last minute or the data of the last second. And this data should be ingested and run through all those very long processes or very many processes, they might be very short, that analyze the data and provide the end data that we would like to provide the organization. And this is also something that we would like to make sure is extremely resilient and with high quality, but we also want it to be as automatic as possible. So LakeFS allows you, again, to ingest the new data of your existing data sets to a branch, test the data, make sure that it holds the qualities that you need to have with the data. By the way, also statistical qualities that allows testing of the quality of the data itself. Is the distribution what we expected it to be? Is the number of users what we expected it to be? And so on and so forth. If the data passes the test, it's being merged into the next step of your production pipeline. And if it doesn't, then the production pipeline is stopped, and you know exactly what is the point where data quality was poor. You can very easily, since you have a full snapshot of what happened, root cause the problem and fix it without exposing low quality data to production. What we have today is everything we run is production. The intermediates are production available. The results at the end are immediately production available. And to communicate around whether the data is tested or not is something that we often do outside of our data management platform. So it will probably be an email. But the data was already written to the destination where it should be read. Or something else we do today, we do all this process on the side on a different bucket. And then in the end, we need to copy it to a different location. That's another workaround. With LakeFS, you don't need to do any of that. Everything is automatic, and the actions are actions of merge. And the actual action that happens behind the scenes is actually the action of metadata pointing from one place to the other. So it's an atomic action, a very clean action, no intermediates lying around in all sorts of buckets that needs to later be deleted. And you have a Git-like environment over your data lake. Okay, so this is LakeFS. I'm sorry. Okay. So as I think you've noticed, although all the tools that I've mentioned in the beginning showed you their logos at the beginning provide data versioning, they are very, very different in the use cases that they take care of. One last thing about LakeFS, we like to say that it is horizontal because it wraps the data lake, unlike the other tools that are provided with an ML ops solution, for example, or with a specific format that are kind of vertical in the way that you need a certain stack all the way to use them properly. While LakeFS just plays nicely with everyone and provides you Git-like operations over your object storage. Okay, so this is the clustering of the data versioning tools. I hope you enjoyed it, and I'll be happy to take questions. Yes, of course, we support MinIO. We support any object storage right now that has S3 interface. And our business model is, we're actually an open source project, so the software is for free. Later on, we intend to provide a managed service or a SaaS solution with the same software that would simply alleviate the DevOps efforts that are needed. And again, if you are a small or medium organization, I don't think the DevOps efforts are actually big, and I think you could probably stay a long time and enjoy the open source. But bigger organizations that go across regions would probably prefer to have that part of their efforts managed, because the management of the metadata in a distributed way becomes complex. But the performance when you're not actually cross-regional is very, very high, and it's sufficient for very large data sets and organizations. So you can stay with the open source for a very long time, or forever if your data operations doesn't grow to gigantic sizes. Okay. So if this was the last question or the only question, I've enjoyed it very much. If you have other questions that come to mind, you can just join our Slack channel for LakeFS and ask me there. Or you can ping me in the Ask Me Later thing here in the conference. I'll be happy to answer. Thank you.